Assalamu alaikum. Welcome to lecture number 33 for the subject of software design and architecture, iTech 4129. I am your course instructor Fahad Anwar. So students, before I start my today's lecture discussion, I would like to give you a little bit recap about our last lecture. So students, if you remember what we discussed in our last lecture, we discussed how model driven architecture is adopted by a object management group in 2001, and then we discussed the basic concepts behind model driven architecture as well, and then we discuss the most important models of this model driven architecture, where actually we see model driven architecture recommends three types of abstract system models which should be produced: computation independent model, platform independent model, and the platform specific models. These three models in very detail have been discussed in our previous lecture as well. And then we discussed the model driven architecture transformations, and this transformation we discussed in very detail and with the help of example as well. And then we see multiple platform specific models, and we also see the executable UML, which is possible using a subset of UML2, which we call executable UML or XUML as well. And then we see features of executable UML as well. We do not discuss all the features of this executable UML. I just give you a little bit overview about these executable UMLs, because this UML we already have been discussed in our lecture number 5, 6 and 7. And at the end of our previous lecture, students, we discuss the relation between the agile methods and the model driven architecture. In this relation we see like if this model driven architectural transformations can be completely automated and a complete program generated from a platform independent model, then in principle model driven architecture could be used as an agile development process, as no separate coding would be required. However, as I am aware about, there are no model driven architecture tools available which can support such kind of practices like regression testing and test driven development as well. So this was a relationship between agile methods and model driven architecture, which have been discussed in our last lecture. So student, this is a little bit recap about our last lecture. So let's formally start the discussion of lecture number 33. So students, here are the brief objectives of our today's lecture discussion. In this lecture we will discuss the benefits of model driven development or architecture, and then we see some kind of issues and challenges being faced by the model driven development, and then we will discuss the more state of the art practices or tools which are currently available for model driven development. And then at the end of this lecture we will conclude about our talk about the model driven architecture, and over this reusability approach. Model driven architecture will be ended at the end of this lecture. So this is our second reusable software reusability approach. In our last week we have been discussed the software product line, and now in this week we are discussing the model driven architecture. And now in this lecture, at the end of this lecture we will conclude our talk about the model driven architecture, and the next week we will be focusing on the aspect oriented architecture as well. So let's start to get the better idea about these terms of model driven architecture. So the students, what are the different benefits of model driven architecture? So students, model driven development is basically faster. So how model driven development is actually faster? So this model driven development actually is the model of a software applications is specified on higher abstraction level than traditional programming language. So this model is automatically transformed into a working software applications by generating code or interpreting or executing the model. So this model driven development tool is told to be 5 times faster than traditional programming languages. So that's why model driven development is faster. And the second point is model driven development is more cost effective. So model driven MDD can be most more cost effective. So the first reason is that you have a shorter time to market because model driven development is more faster, as we discussed in point number 1. So the second reason is that it is possible to do it at lower cost. The next one is model driven development leads to increased quality. How? So because students, a software application is specified in a high level model, like which is executed by an engine or transformed into code, like quality of the application depends on the generator or engine. So hence we can say that the quality can increase a lot because we can let our best people work on the generator. So that's why model driven development leads to increased quality. The next one is about model driven development is less error prone. How it is less error prone as compared to traditional approaches? So everything having experience with delivering a new software applications knows that testing costs a lot of time and expertise. So model driven development ensures that you can focus on testing the functionality of the application, for example the acceptance testing, etc. So that's why model driven development is less prone. So the next one is about model driven development leads to meaningful validation. So what does it mean actually? Students, you can say like even the functionality itself is less error prone, like when using an model driven architecture approach, because meaningful validation can be executed on the high level models. So when using traditional programming languages, you will have some syntax checking in your interactive development environments, and maybe even some static code analyzers. So that's why this actually leads to more meaningful validation. And then let's move to next slide. And then another benefit is about model driven architecture is model driven development actually results in software testing which is actually less sensitive to change its personal. So what does it mean? So students, when we used a model driven approach, the resulting software will be less sensitive for changes its personal. So as you don't need to technical specialist anymore to build software, you can draw from a large pool of people, etc. So that's why this results in software which is actually less sensitive to changes its people, because it is not a people oriented, because it's a more a technological oriented approach. So sorry. So the next advantage is model driven development empowers domain experts. So because this model driven development enforces the separation of concerns and skills, like domain experts can focus on modeling the domain while technical specialists focus on building the tools needed for model driven development. So we can say that domain expert and one type of domain experts can be focusing on modeling the domain, while the technical specialist can be focused on the building the tool which is needed for the model driven development. So that's why this model driven development enforces the separation of concerns and skills between the modeling the domain and the building the tool for the model driven development. So that's why this approach empowers the domain experts. And the next one is about this approach lets advanced programmers focus on the hard stuff. So what actually this point is about? So like students, this model driven development actually advanced developers do far less repetitive work. They can focus on the creative aspects of their work, like you can say they can focus, for example, on building the MDD tools. Like they can also mentor junior developers or domain experts, or they can pick up the hard parts of application buildings, etc. And then model driven development captures the domain knowledge as well. So this point is pretty straightforward. Like this actually about model driven development is that you are not only creating the software, but you're also capturing the domain knowledge in formal and high level models as well. And the last one is about the model driven development provides up to date documentation as well. So when using MDD approach, you will not suffer from incomplete or outdated documentation, because the model is documentation. When using the right abstractions, the models are readable for domain experts and business owners as well. So that's why this approach also provides the up to date documentation as well. So students, not only these are the benefits of this model driven development, but these 10 to 12 benefits which I have discussed in these slides are the most main main benefits of any model driven approach. So where we have some benefits, so there also exists some kind of issues as well. So what are the different issues which are actually being faced by this model driven architecture? So the first one is about MDA model types. So what does it mean? Like, different models of model driven architecture support different ideas, doctrines and methods, etc. So in these instances, model driven architecture standards, which include UML and XML, then transformed is performed in the planned process, but model types are not integrated. For example, platform independent model and platform specific models. So that's why this model types is a main issue in this model driven architecture. And the next issue is about concrete process inclusion. So what does it mean? So like, various methodologies claim to be model driven architecture based do not process towards concrete processes, although they satisfy the process needs. So the next aspect is about coverage of the generic life cycle. So in coverage of the generic life cycle, the whole issue resides to what extent phases and activities of the journal software development life cycle is all covered by the methodology is also a main concern of this model driven architecture approach, because as we discussed earlier, model driven architecture is only focused, or you can say model driven architecture focusing on the design and implementation stage of the software development, and this is the only area where model driven architecture will be focusing. And this model driven architecture approach will not cover the whole aspect of software development lifecycle, which is actually covered by the model driven engineering, which actually involves the all aspects of software engineering process model. So that's why coverage of the generic lifecycle in this model driven architecture is also an important issue, because this only focusing on the design and implementation stage of software development as well. And the next step is about process precision. So what is process precision? Like, students, you can say, like, while developing the software, so it should define the process efficiently and effectively by the experts like involved in the development process of model driven architecture. Methodologies are actually responsible to describe the process, but not in an effective and efficient manner. For example, this we can say that model driven architecture and do not fit into the behavior of their processes, etc. So that's why process precision is also an important issue in this model driven architecture. And the next one is about the application scope. So like, some model driven architecture methodologies are not general purpose and they are not applicable to all domains. For example, model driven architecture is application of web information of sciences, and Modatel focusing on the distributed application. These are the domain specific. Like, Midas is application of web information systems, and Modatel only focusing on the distributed applications. So there are different specific applications which are only concerned about the specific domain areas. So the next one concern is the security, important aspect, students. So like security, a software product can be secured enough, like, if this factor is considered from very beginning. When security is handled, then security protocol schemes are occurred at minimum level. Like, model driven approach for the development of security vital applications is helpful, like in producing an execution and official model from the identical platform independent model. So that's why they are required to guarantee a correctness and security as well. So what and the next important issue in this model driven architecture is real time system. So what is a real time system? So developing a real time system based on this model driven architecture is also a significant. So some efforts have been made, but it is partially, it can solve the difficulty associated with the function of real-time system. This is not available in traditional development methodologies, etc. So students, these are the different issues which are actually being faced by model driven architecture. So there are some other issues as well. So these are the more common issues which are actually currently being faced by model driven architecture. And students, there are some challenges of model driven architectures are as well. So what are the different challenges of model driven architecture? So students, before we start about our discussion of this model driven architecture challenges, I have a question. So my question about I am leaving you with a question to brainstorming about this question, like why models were selected as the central object in this design principle. So my question to you is, in this model driven engineering or model driven architecture, why their models were selected as a central object in this design principle? So you should note on this question about different models were selected as a central object in this design principle. My question is, why these models are actually selected as a central object in this model driven architectural paradigm? So I will answer you this question in the later part of this lecture as well. So there are some challenges of model driven architecture as well. These are the not issues but are the difficult tasks to obtain in the model driven architecture. Like in today's time, our industry is actually becoming very challenging. So because the reason is softwares are getting large day by day, and they are getting complex day by day due to its distribution, due to its distributed property. So developers need to always are trying to maintain the quality of software systems so that they can ultimately meet the expectations of their stakeholders. So there is a reference for a study actually conducted by this Standish group, has shown totally 29% of the projects were successful in 2004. Moreover, in typical software development lifecycle used in companies or organizations or any firms, it can be easily observed that routines are repeated in terms of some same steps, same tools and tests. So to improve these routines, the model based approaches are vastly used. So that's why these model driven approaches are currently vastly being used. But for utilizing these model driven architectural approaches, there are some also challenging being faced by the model driven community as well. So what are the different challenges which are currently being faced by the model driven development community? Is time and budget. So model driven architecture development is designed to reduce the cost and delay at each stage of development life cycle. So it is fundamental if we want to make our software profitable. So students, you can say, as many tools and transformation took place in model driven architecture, so it is considered a challenge. Because what kind of transformations have been made in model driven architecture, we also have been discussed in the how model driven architecture has been adopted by the OMG group, have been discussed in previous lecture as well. So that's why I don't need to go into more details about how that challenging work was to develop the MDE architecture was. So the next important challenge is about the formal method. So in the formal method is actually about the software development. In software development actually, model driven architecture like explain the solutions to the problem by providing any formal methods, like no other method is used. And using utilization of these formal methods are not a very easy task. Like there are different languages are utilized in this formal methods, like Z specification language is very a popular language, is which is actually utilized by the formal method, and it is a very domain specific language. And utilization of these formal method languages is not an easy task. So it is also an open issue. So another important issue is challenge is about improvement of traditional SDLC. So as students, model driven architecture is a further step to improve the traditional software development lifecycle methods in each step. Like it's starting from requirement analysis, specification, design, coding, and the maintenance. This MDA is a set of framework which is actually developed by a object management group. So some of the challenges of this model driven architecture are to identify applications of transformations to abstract descriptions as well. So that's why there is a need to improvement of traditional SDLC as well. So the next one is automation. So automation is also a challenging task in model driven architecture. Like to develop an architectural design, it is an important step in model driven architecture which actually develops an architect experience and resource constraint as well. So students, due to this purpose, automated methods are unachievable yet. So the next important challenge is multimodal consistency. So what is multimodal consistency? Is multimodal consistency, student, is another important challenge being faced in model driven architecture. So there is a need to understand the relationship between these models that should maintain a multimodal consistency, as change in one model affect the other models in the multimodal, and these models already have been discussed in the model driven architecture transformation diagram as well. So student, these are the different challenging which are currently being faced by the model driven architecture. So there are some other challenges are also available, but these five six are the top challenges which are currently being faced by the model driven development community. So students, now we are moving towards the end of our lecture discussion. So students, there are the different model driven tools are also available. So there are different tools. I provided you with the links as well. So so student, these are the different tools as well as I am aware about these tools. So however, as far as I am aware, these are the model driven architecture tools which I will present in the coming 2-3 slides as well. So these are the different model driven architecture tools. You don't need to memorize these tools. So it's just for your information, like M2M tools, in which we have a active source, and I also pasted a link for each against of these tools. You can just go out there if you are willing to work in the future as well. Android MDA, Eclipse, ATL and QBTO are also other important to MDA tools of M2M and M2T as well. And there are model driven engineering application builders as well, like you can see artisan software tools, and there's Studio as well, like Aspectize, Blue Age, Jaxico Clario, Jaxico Springer Fuse, and Mendix as well. So these are the different tools which are utilized by the model driven community. So there are the language workbenches as well. So language workbenches are like EMF text, Eclipse TMF text as well. JetBrains, SpoofX are the important workbenches utilizes by the model driven community. And then there are some domain specific benches as well. You can just go through yourself as well. And there are the model driven engineering user interface design tools as well, like Eclipse E4, uh, Wasabi as well. And then there are some modernization tools about these model driven tools, like Eclipse Modisco, like Maya software, like Obio Agility. So these are the different tools model which is actually currently provided by the model driven community. So these are the some popular and state of the tools which are actually I am aware about. These tools are about the model driven architectural development. So other tools, case tools with the model driven engineering capabilities are like Model IOSoft Modulo, like No Magic Draw, and the Spark system is also an important enterprise architect as well. Some XSLC based tool, Exomega is also an model driven tool as well. So student, these are the different tools about model driven development. So you don't need to memorize these tools. So these tools are just for your information. If any one of your students is willing to work in this model driven architecture in future, so these are for your information, and their links are also pasted over here. So you can just visit their website and you can get better idea about their tools, how actually they work. So students, now we are actually heading towards the end of our today's lecture of our this model driven architecture development. So students, I am concluding my talk over here is that this model driven engineering is actually an approach to software development in which a system is actually represented as a set of models that can be automatically transformed to executable codes as well. And this model driven architecture or model driven engineering are basically two same things. Like MDE has a wider scope across the SDLC, while this model driven architecture has only focusing on the design and implementation stages of software development, and this model driven architecture is actually focusing on the design and implementation, which actually uses a subset of UML models to describe a system. So student, till here our discussion about a second reusability approach of software system model driven architecture is ended, and now our lecture number 33 is also ended.